Lesson 8.1 on error approximations. Alternating series remainder. So if a series is alternating, to know what the error approximation is, I just need to know the next term. So like in example number 1, we're just going to first do the sum of this series with the first 6 terms. So plug in 1, then 2, then so on. So if you plug in 1, if you plug in 2, and I'm just going to go through it. If you plug in 3 and simplify it, and then you could use your calculator, but I'm just going to tell you the answer. So we have 1, 2, 3, 4, 5, 6. So the first 6 terms, if you use your calculator, that would be the sum using the first 6 terms. And this says find the upper bound for the remainder of the approximation. So the next term would be 1 over 7 factorial. That's the 7th term using this formula that's in there. So if I use my calculator, let me show you again where that is in your calculator. We're just going to go 1 divided by 7. Press menu, then probability, then factorial is the first one. And then do it. And then you get 0.000198. And that is the error approximation. So it's the next term after. And if it says find the upper and lower bounds, well, the lower bound is what this answer is because we keep adding numbers to this one. So that's the lowest it could be because I'm adding and then alternating. So the next one I'm adding this, and then what I'm subtracting is going to be smaller than this, and then adding. So that's the lowest possible answer. And then the largest possible answer for this series and then you would add this 0.63194 and add it to the next term. And that would be your error approximation. And if you would add that, that's 0.6321429. But you would take the first 6 terms and the 7th term, you would add to it, and that would be the error approximation. All right, look at example number 4. Approximate this with an error of less than 0.001. So we are going to write out this series. So I'm going to plug in 1 and then, or plug in 0, then 1, and so on. So if I plug in 1, if I plug in 0, if I plug in 1, negative 1 to the 1, it's negative. So when you simplify it, it's 1/2. And then I'm not even going to simplify the next one. And it alternates, just plugging into that formula. What I want to do is recognize which one of these terms is smaller than 0.001, and that's where I would stop. So if I want an error of less than 0.001, like I know 1/2 is bigger than that. I know that, do I know 1 over 4 factorial? Maybe I don't. So if I have 1 divided by 4 factorial, see, 0.041, so that's bigger. If I have 1 over 6 factorial, close, but 0.0013 means it's a little bigger than 0.001. That means the next one, which would be 1 over 8 factorial, .00002, that one's smaller. So that's when I would stop. So with an error of less than that, the next one after this one is too small. And so you go up to the number that isn't smaller than 0.001, and that's what it would be. And if you would add that with your calculator, you get 0.54028. Use an elementary series. So that's from the other lesson in terms of like what form is this in? So this is in the form of cosine from the other unit, from the other lesson. So that's just cosine 1 as an elementary in terms of seeing it. The even numbers on the bottom, the factorial, cosine 1, and that's approximately with your calculator 0.54030. So that as an elementary series, that's the exact answer. You can see the using that and not using how close they are in terms of how the answers with each other. All right, so if it's an alternating series and it converges, to find that error bound, you just need the next unused term. So whichever term, the next one that you're not using, that's your error bound. So it's fairly simple in terms of that. The next one is when it's not alternating. It's called Lagrange remainder. And so when it's not alternating, we have to be able to do some other work. So let's look at that. Turn the page. So choose a value of z which makes this factor a maximum. This may be at the center at the x value or of f, or is to be evaluated, or you may know the maximum value. So if it's Maclaurin, then the center is at 0. And so if I want to estimate e to the 2, remember e to the x would be 1 plus x. We don't need x minus 0 with 0 at the center. And then x squared over 2, x cubed over 3 cubed. You get the idea. X fourth over 4. And so on, all the way to 10, following that. If I then, instead of x, if I put in 2 and then use my calculator, all the way to 2 to the 10 over 10 factorial, I will save you time. If you put all of that in, you get 7.38899. Now, in the Lagrange form, in terms of this, and we'll use that there, the error approximation is going to be less than or equal to this e to the 2 times the next term. So again, it would be 2 to the 11 over 11 factorial. And that's about 0.000379. So that next term. In example number 8, this is the fifth term, is 700 sine x, and it's centered, well, we have x is equal to 0.7. It's a power series, centered at 0, right? So it's Maclaurin again. Find an upper limit to the error when the fourth degree polynomial is used. So if the fourth degree is used, then I need 700, and then the power series for sine. The next term after the fourth is what I'm looking for. I'm looking for the next one, which is the fifth. So then I would take 0.7 to the fifth over 5 factorial, and I would get 0.9804. So that's that next term that gives me that error approximation. For example number 9, you're told a function, the sixth term, it's a positive decreasing function. Find the error bound for the fifth degree Taylor center. So it's not centered at 0, it's centered at 4, so you'd be using x minus 4 used to approximate 4.1. So we need the next one, which is the sixth one. Now it's going to be the absolute value of this, and so we need the sixth term, which is this. And it's important to know it's decreasing in terms of what's happening. So if it's decreasing, then that's the max value. And then because it's centered around x minus 4, you would go 4.1 take away 4 when you plug it in. So the fourth term, centered at 4, and then 4.1 take away 4 would be 0.1, and that would be to the exponent 6 over 6 factorial. And that's it. We need to practice, right? And keep practicing our series. All right, Mr. G Math, over and out. Until next time, let's do our homework together.